Hello and welcome to this new video which is about quantities in motion. So let's start. So as we have seen before that the first step of any physics process is to observe an event and measure some quantities regarding it, and quantities will be the thing which we will be interested in regarding that event. So for measurement of the motion we'll also have to define some quantities, and those quantities will depend on what questions we want to ask, what things we want to measure. So let's assume motion of something, and in this particular case motion of a basketball from this point A to some final point B, and this is the path of the motion. So let's say that you observe this event. What all question you might ask? So the first question you might ask would be how much length has it covered? Then you might ask how much time it took. Then you might have asked that how fast was it going? And finally, was its fastness changing or was it going with the same fastness? So fastness changing. So with respect to all of these questions, we'll try to define a new quantity and we'll try to measure them. Alright, the first question you asked was how much length it covered. As it turns out, there are two answers to this question. One answer would depend on how much actually has it covered, that is length of this actual path. So that term is described as distance. So distance is defined as the length of actual path covered by any body. So you are going in a car and you're taking turns left and right and you're doing in a curve also, but the odometer, the device in your car that tells you how much you have covered the length, is telling you the distance. So you can subtract the initial distance that covered by the car from the final distance covered by the car to get how much distance you have actually covered. But another answer could also be how much has it been displaced from its position. So I'll give you an example. Let's say I'm moving in a circle. So I start from here and I go and I come back to exactly this point. Now my odometer will tell me that I have moved some distance. That will be 2 pi r, right? Have I displaced from my position? The answer to that question is obviously no, because I'm at the exactly same position. My initial and final position is same, isn't it? So I have not displaced, but I have traveled some distance. So there are two answers to this question. So let's see which answer gives me a better idea of the movement. Let's say I'm here and my friend, who's he? Iqbal. Yeah, Iqbal is also here. Now Iqbal travels to this distance like this. It reaches this point here, calls me and says, bro, I'm 10 kilometers away from you, come pick me up. Now will I be able to pick him up? The answer to this question is no, because 10 kilometers he could go in this direction, he could go in this direction, he could take a curved path, he could do anything. He could do infinite number of things with this 10 kilometers, isn't it? So that 10 kilometers is not giving me much information. But let's say he gives me another information. He gives me that I am at 6 kilometers in northeast direction, not exactly northeast, but let's say 30 degrees from the east towards the north. Now will I be able to pick him up? Obviously, because there's only one way where 6 kilometers straight line goes at exactly 30 degrees from the east direction. So displacement gives us a better idea about the motion of a body, or it gives us more information about a body because it has direction attached to it. So we thought, okay, why are we just doing with distance and displacement? Let's do it for all the physical quantities. So we arrive at the idea of scalars and vectors. Hence we have categorized the physical quantities into two categories. They are scalar quantities and vector quantities, are also called as scalars and vectors. Now let's just go through the definition and then we'll discuss what exactly does it mean. Scalar quantities are quantities which has only magnitude. It has only a number attached to it. Like if I give you one example, it would be mass. So mass is just 5 kg. Vector quantities on the other hand has magnitude as well as direction. Like we discussed one quantity, displacement, that was like I moved 5 meter in east direction. So it has a magnitude attached, that how much it moved, as well as a direction attached, in which direction was it moving. So why not give every quantity a direction? Because as it turns out, not every quantity needs direction. In fact, if you give direction to some quantities, it makes that quantity senseless. It doesn't make sense. Like, what if I tell you that I have 5 kg mass in north direction? Is it making sense? Or temperature of your body is 50 degrees Celsius in upward direction, or energy is 100 joules in downward direction. So these things doesn't make sense. And that's why the idea is simple. See, we are not given with any pre-given book which says that we have two types of quantities, scalars and vector, and mass will be scalar, displacement will be vector. We don't have any book. We decided on ourselves that this will be scalar, this will be vector. And the decision simply depends upon, does adding direction to a quantity makes it senseless or gives more information about that quantity. So if it makes it senseless, it will be a scalar quantity, and if it gives more information about the quantity, like let's say force says as 5 Newton in downward direction or 5 Newton from leftward side. So adding direction to force makes more sense, gives more information about what actually is going on. Force is made to be a vector quantity. Now let's discuss the second question we asked, how much time it took, which is pretty simple to measure. Let's say here is the initial position, here is the final position. It went from here to here like this. Now there are two ways to measure the time. One would be using a clock. So that will tell you some initial time t1, that yeah, time is 10:51. Now final time would be t2, let's say 10:53. Then you know what was the time that took for the event. That would be t2 minus t1, which we also call as delta t. This delta is a Greek alphabet which symbolizes change in. So whenever you see delta, just replace this by the word change in. So delta t means change in time, delta f means change in force, delta x means change in position. Okay, what's the other method? The other method would be simply to start a stopwatch. So your initial time will be 0, and whatever your final time t, that is the period. T minus 0, that is the time taken for that event. The third question we asked was, how fast was it moving? How fast? So for fastness, again it turns out there are two ways to answer this question on the basis of whether we want direction or whether we don't want direction. So speed is the scalar version of this problem. So speed is defined as distance over time, and similarly velocity, which is the vector part of this problem, that will be defined as displacement over time. So this gives an idea of how fast something is moving. So let's assume there is a race from point A to point B, and there are two guys, let's say X and Y. So if X travels the same distance in lesser time, then X is traveling more fast. So fastness must be inversely proportional to time, isn't it? Simple. Second race would be, let's say they both have to travel for the same time and see who's traveling more distance. So let's say A travels this much, B travels this much, then obviously B is more fast. So that should be proportional to how much distance or displacement that thing is doing. As it turns out, speed comes out to be distance over time, velocity comes out to be displacement over time. So units will be distance, displacement, both will be measured in meters. This will be meters per second, and this would also come out to be meters per second. Now for example, let's say you're moving in a circle. The circle gives us more idea about what exactly is the difference between distance, displacement, speed and velocity. So let's say I traveled from here to here, half the circle. Now my distance is 2 pi r divided by 2, that is simply pi r, isn't it? But my displacement, if you look at it, is the length of this straight path, as displacement is the shortest length of path between 2 points, which is obviously a straight line. So displacement would be just 2r, and let's take the time taken to be t. So t was the time taken. So if you calculate the speed, that would come out to be pi r by t, and if you calculate the velocity, it would come out to be 2r over t. But if you remember, I said velocity is the vector part of this problem. That means velocity must have direction, and I just gave you only magnitude, that is just 2r by t meter per second. So what's the direction? So the direction of velocity is simply the direction of displacement, because it's displacement over time, right? And what is the direction of displacement? Direction of displacement is from initial point A to final point B. So you can say velocity is in east direction. Alright, one more division. So again, speed and velocity both can be of two different types, that is average velocity, instantaneous velocity, and average speed and instantaneous speed. Now let's see what are they. Now again, let's go through the definition first. Average velocity is defined as total displacement over total time taken, and similarly average speed would be total distance over total time. You might ask, is the same thing, isn't it? I just added total, and there also I had to calculate total only, right? So yeah, you're correct in the sense that it's the same thing here. When we talked about it, it was an idea that what exactly speed would be, and here we are saying that I was given an interval of time. That means from point A to point B, let's say here t was 0 and here time was equals to some t. So now time taken is t, and if you calculate the average velocity, that would be displacement over time, and if you want to calculate average speed, that would be the distance over time. So it gives us an idea that what was my average kind of velocity. It doesn't mean we traveled all of that distance with the same speed or all of that displacement with the same velocity, but it just says that if you would have traveled with that speed or velocity, then it would have taken the same time to reach there. One important point to remember is that average velocity is not the same as the average we take in mathematics. It's not the same that n1 plus n2 plus n3 plus n4 dot divided by total number of items. It's not the same thing. Just worry about that this is the definition of average velocity, this is the definition of average speed, and don't take it like v1 plus v2 plus v3 by 3. Alright, now what do we mean by instantaneous velocity? Instantaneous velocity is simply velocity at any instance. The speedometer of your bike or your car shows you what? The velocity or the speed at that particular instant, at that particular moment. So how fast are you going at any particular moment? If you want to know that, what question you are asking? You're asking how much is your instantaneous velocity or instantaneous speed. Now in this thing you can say that instantaneous velocity and instantaneous speed will have the same magnitude, because at any moment how fast you're going will have the same value, isn't it? Just that velocity will have a direction and speed will be without direction. Now let's discuss one more thing. So velocity is defined as displacement over time taken, isn't it? Now if I gave you no time, that is no period of time, I asked you that what is your velocity at this particular moment, let's say. Now I'm asking you at this particular moment. I'm not saying that from this moment to, let's say, 10:31 and 50, something like that. So I'm not giving you any period. I'm just giving you that at this moment what is your velocity, right? So that will come out to be 0. Now in this 0 time, how much displacement I did? That would be obviously 0. So we got a problem. How do we calculate instantaneous velocity? If I don't give you time, that will be 0, and we get 0 by 0, which is obviously a garbage value, isn't it? Now if you want to know why this is a garbage value, we can spend a little bit time on that. So when we say we are dividing something, let's say 25 by 5, so you know the answer, right? It's 5. But what actually we are doing is repetitive subtraction. But what exactly we are doing is asking the question that how many times do I have to subtract 5 from 25 to make 25 0? So that would take 25 to 20, 20 to 15, 15 to 10, 10 to 5, then obviously 5 times. When we ask a question like, let's say 20 by 0, then we are asking the question, how many times do I need to subtract 0 from 20 to make 20 0, which obviously mathematically is impossible. So you can say that it's not defined, it's not correct, it can never happen. But in physics you can also say that it will be infinity, or it will be tending to infinity, because in physics is about measurement, and let's say you have to calculate some quantity, that resistance equals to potential difference by current, and you got the current as 0, so you'll put in the equation as 0. But will it be correct? Will it mean that there is resistance is not defined? It might also be that current which you have measured was something, but your device was not precise enough to measure that amount of current. Your device was only precise for milliamperes, but the current was microamperes or nanoamperes. And if this is not exactly 0, this is 0.00000 something, it will make 20 0 after a very huge number of times. So we say that it's actually tending towards infinity. It's just the same thing that we say in maths, parallel lines never meet each other. That's correct. If the angle between two lines is exactly 0 degree, then they'll never meet each other. But physics deals with reality. So if we make two parallel lines, there is a high chance that there might be some angle. It will not be exactly 0 degree. It will be 0.0000. Even if there is very small amount of degree between them, then they can meet after a very long distance, isn't it? So this is also said to be not defined, or also said to be like tending towards infinity. But coming towards this part, 0 by 0, that gives me a garbage value. Why? Because you are asking the question, how many times do I need to subtract 0 from 0 to make 0 0? Isn't it? Right? So that obviously you can say you don't need to do that, it's 0. But what if I tell you do it one time? Okay, so 1 is also the answer, 2 is also the answer, minus 1 is also the answer. In fact, everything from minus infinity to plus infinity will be the answer of this question. So we have a huge problem, that how to calculate instantaneous velocity of a particle, and that problem is solved via a mathematical tool called calculus that we'll study in later portion of these lectures. Now let's take a small problem to have a grasp of whatever we did in previous portions. Alright, so the problem is pretty simple. It says a body starts from point A, goes to point B. It travels with 30 meters per second, but from B it also comes back with 20 meters per second. What is the average speed of this motion, right? So before even we do anything, we can directly say average velocity of this motion would be 0, because displacement is 0. It's going like this and then also coming back, right? So net displacement is 0, average velocity is 0. How about average speed? Now average speed is not 0 because distance traveled is there. How much is it? Not given in the question. So what do we do? If it's something we think that it's not given in the question, it should be, then take it as a variable. Let's say the distance from A to B is D. So distance traveled is 2D. What's the time taken? I also need time taken, right, to calculate the average speed. Now I don't know the time. Time taken, let's say in going was T1, while coming back it's T2, because it will not be the same, right? It's going faster from A to B but slower from B to A, so it will take smaller amount of time. T1 will be smaller in going there and longer amount of time in coming back. T2 will be larger. So time taken is nothing but T1 plus T2. Alright, now can we relate T1 and D? Yes, we can, because we have one formula. D equals 30 into T1, or 30 equals D by T1. So T1 is nothing but D by 30. Similarly, you can say that D is also equal to 20 into T2. So T2 is nothing but D over 20. Now let's put it in the formula. What was the formula? Average speed is nothing but total distance, which is 2D, over total time, T1 plus T2. Let's substitute D over 30 plus D over 20. D, it looks like it gets cancelled, so it's just 2 divided by 1 over 30 plus 1 over 20. So that will be 30 into 20, and here will be 20 plus 30. That comes out to be 2 into 30 into 20 over 50. Cancel, cancel, cancel. 6 into 2 into 2. That would be 24 meters per second. Now for most of you it would be surprising, isn't it? Because you would have thought that the answer is simply 25, 30 plus 20 by 2. But as I told you earlier, it's not the formula. It's not V1 plus V2 plus V3 by N. Correct? So don't use that. Always go by the exact formula, total distance over total time, or total displacement over total time. Alright, let's answer the final question. The final question was its fastness changing or not changing? So we have defined a quantity for it, which we call acceleration. So acceleration is the measure of how fast velocity of a body is changing. Remember, velocity, not speed. Acceleration is about velocity. So if the velocity of a body is changing, that means there is some acceleration. If the velocity of a body is not changing, that means there is no acceleration. So acceleration is simply defined as rate of change of velocity. Right? So we can say A, which is acceleration, equals V2 minus V1 over time. So let's imagine a scenario. Point A, point B, a body is traveling from here to here. Here its velocity was V1, here its velocity was V2. The time taken to change this velocity from here to here was T. So acceleration will come out to be V2 minus V1 over time taken. Rate of change of velocity. What will be the unit? Unit simply will be unit of velocity, which is meter per second over second. That is meter per second square. So if you have some value, let's say acceleration is 5 meter per second square. So what it exactly means is simply it's 5 meter per second. That is, velocity is changing by 5 meter per second every second. So if it's starting from 0, after 1 second its velocity will be 5, after 1 second its velocity will be 10, after 1 second more velocity will be 15, and so on. So you can also assume that acceleration can also change. Let's say acceleration is something like 5 plus time. So at time t equals to 0, acceleration is 5, but at t equals to 1, acceleration becomes 6, right? So that can also happen. So for that also we have defined a quantity, but that quantity is not useful, so we'll not go into that. I'll just give you a name of it. It's called jerk. So jerk would be rate of change of acceleration, that is change in acceleration over time, a2 minus a1 over time. Alright, to the summary of this video. So in this video, what all things we learned? So first thing we learned that to start any physics, we start with measuring some parameters about an event which we are observing, and to measure those things we need to define some quantities. So the first quantity which we defined was distance and displacement, which gave us an idea of how much something has moved. So distance was the length of actual path taken, displacement was simply the shortest path between initial and final position. So distance is this guy and displacement would be this guy with the direction quotient as well. Then we asked how fast was it moving. So how fast was it moving was defined again in two parts, that was speed and velocity. Speed was the scalar part of it and velocity was the vector part of it. So speed will not have any direction and velocity will have a direction. We also saw speed and velocity are of two types, average speed and instantaneous speed, average velocity and instantaneous velocity. Average velocity will be defined as total displacement over total time, and average speed was total distance over total time taken. Instantaneous speed was speed at any instant, and if you give that thing a direction that it's going with 20 meters per second at this point in time in east direction or north direction, then that will be its instantaneous velocity. Finally, we also discussed, is there any quantity which can describe us that how fast its velocity is changing, or its velocity is even changing or not. So we defined a quantity called acceleration, which was defined as final velocity minus initial velocity over time taken. So if final velocity is same as initial velocity, then acceleration is 0. If final velocity is not equal to initial velocity, let's say it's greater than initial velocity, then acceleration will come out to be positive. That means velocity is increasing. If final velocity is less than initial velocity, then acceleration will come out to be negative, and it will be also called as retardation or deceleration, which simply means that velocity is decreasing over time. Okay, so now we are equipped with quantities. Now we can deal with motion head on. So we'll start with types of motion, and one by one we'll go into different types of motion and we'll study them graphically as well as numerically. Thank you for watching. Good day.